All right, let's go. Number 10, Project A119, the secret plan to nuke the moon. In 1958, months after the Soviet Union launched Sputnik and shattered American confidence in the space race, the United States Air Force commissioned a classified study at the Armor Research Foundation in Chicago. The question on the table was not theoretical. It was operational. Could a nuclear bomb be detonated on the moon visibly from Earth? The context was one of institutional panic. Sputnik had launched on October 4, 1957, and the United States had watched in stunned silence as the Soviet Union became the first nation to place an object in orbit. American rocket programs were failing publicly and repeatedly. Military leadership was desperate for a demonstration of technological power so undeniable, so visible, that the entire world would be forced to acknowledge it. The moon, it turned out, looked like a billboard. A 10-member team was assembled under physicist Leonard Reifel at the Illinois Institute of Technology. Among them was astronomer Gerard Kuiper and a young doctoral student from the University of Chicago named Carl Sagan, whose specific assignment was to calculate how a nuclear debris cloud would expand in near-vacuum conditions and whether it would be visible from Earth with the naked eye. The target would be the lunar terminator, the boundary between the moon's illuminated and dark sides, to maximize the drama of the flash. The project was canceled in January 1959, reportedly due to concerns about nuclear contamination of the lunar surface, the catastrophic consequences of a launch failure raining radioactive material back onto Earth, and the eventual judgment that landing a human on the moon would be more politically effective than detonating a weapon on it. 8 project reports were written. All were destroyed in 1987. The existence of Project A119 remained classified for nearly 45 years, revealed publicly only in 2000 when Reifel broke his silence in a letter to the journal Nature following an inadvertent partial disclosure in a biography of Carl Sagan published the previous year. The Soviet Union, it later emerged, had its own parallel program. Before either superpower sent a human being beyond Earth's atmosphere, both had seriously studied whether to announce their presence in the cosmos with a nuclear detonation visible to every person on the planet. Whatever else humanity eventually does in space, it came remarkably close to beginning with an explosion. Number 9. Operation Starfish Prime, the bomb that rewired Earth's magnetic field. On the night of July 9, 1962, hotels in Honolulu were offering rooftop parties they advertised as rainbow bomb viewing events. The sky above the Pacific Ocean, over 1,400 kilometers from the detonation point, lit up in cascading curtains of green, white, and vivid red. What the rooftop party guests were watching was a 1.4 megaton thermonuclear warhead detonating 400 kilometers above the surface of the Earth. Operation Starfish Prime was part of a series of high-altitude nuclear tests grouped under Operation Fishbowl within the larger Operation Dominic, a joint effort of the Atomic Energy Commission and the Defense Atomic Support Agency with the warhead designed at Los Alamos Scientific Laboratory. The stated scientific goals included studying nuclear effects in space, assessing electromagnetic pulse reach, and exploring the potential use of high-altitude detonations as anti-ballistic missile interceptors. The effects on Earth's radiation environment, scientists confidently predicted, would be minimal. They were wrong. The detonation released approximately 10 to the power of 29 electrons into Earth's magnetosphere, creating an artificial radiation belt that intensified the inner Van Allen belt by several orders of magnitude. The electromagnetic pulse disrupted street lighting and electrical services in Honolulu, hundreds of kilometers beyond the predicted range. Then, in the weeks and months that followed, satellites began dying. Telstar 1, launched by AT&T the day after the detonation, the world's first commercial communications satellite, sustained radiation damage that eventually destroyed it. Britain's Ariel 1, the Soviet Cosmos 5, and at least 4 other spacecraft were crippled or destroyed by the lingering radiation field that no one had predicted would exist. Atomic Energy Commission. Chairman Glenn Seaborg wrote in his memoirs that the results came as great surprise and dismay. The artificial radiation belt persisted for at least 5 years, with some estimates extending to a decade. As published in Science magazine in a 2021 assessment, a Starfish scale event in the current orbital environment, which contains thousands of times more active satellites than existed in 1962, would be dramatically, perhaps catastrophically, more destructive. The most unsettling dimension of Starfish Prime is not what it destroyed in 1962. It is what it demonstrated about the relationship between institutional confidence and actual consequence. The scientists were not careless. The planning was extensive. 27 additional instrumented missiles were launched to measure the effects, and still the outcome exceeded every prediction in every direction. The universe does not negotiate with certainty. Number 8. Project West Forward, the day the U.S. ring the Earth in 480 million copper needles. On May 10, 1963, a ground command transmitted from a U.S. military facility triggered the release of a canister from low Earth orbit. Inside were 480 million hair-thin copper needles, each precisely 1.78 centimeters long, packed into blocks of naphthalene, the chemical compound more commonly known as mothballs. Designed to sublimate in the vacuum of space and release the needles in a uniform dispersal pattern, the United States military was attempting to build the largest radio antenna in human history by ringing it around the entire planet. Project West Forward, also known as Project Needles, was conceived in 1958 by Walter E. Morrow at MIT's Lincoln Laboratory on behalf of the Department of Defense. The reasoning was grimly pragmatic. At the height of the Cold War, long-distance military communications relied either on undersea cables, which the Soviets could cut, or on the natural ionosphere, which was unpredictable and vulnerable to solar activity. Morrow's proposal was audacious. Deploy a belt of passive copper dipole antennas in polar orbit at approximately 3,650 kilometers altitude, where they would reflect radio signals at precisely 8 gigahertz, creating a reliable global communications layer that no adversary could jam or destroy. The needle length of 1.78 centimeters was not approximate. It was exactly half the wavelength of the target frequency because physics demanded mathematical perfection. The first attempt, launched October 21, 1961, on a Midas IV satellite, failed spectacularly. The needles clumped rather than dispersed, producing a handful of useless metallic tangles in orbit. The 1963 attempt succeeded partially with somewhere between 70 and 190 million needles, roughly 15 to 40% of the payload, dispersing successfully into a toroidal belt approximately 15 kilometers wide and 30 kilometers thick. Voice and data transmissions were successfully relayed between Massachusetts and California. The experiment worked. Briefly, the international response was immediate and hostile. The International Astronomical Union formally protested. Scientists worldwide objected to the unilateral decision by a single nation to permanently alter the orbital environment shared by all of humanity. The controversy contributed directly to a consultation provision in the 1967 Outer Space Treaty. The individual needles deorbited within a few years as designed. The clumps from both the 1961 and 1963 deployments did not. As of April 2023, NASA's Orbital Debris Program Office was still tracking 44 clumps larger than 10 centimeters, objects that have been in orbit for over 60 years, monitored by the same MIT Lincoln laboratory that put them there. What does it mean that the oldest human-made objects currently circling Earth are failed clumps of Cold War copper wire packed in mothballs? And what does it mean that the first serious international debate about humanity's right to unilaterally alter the orbital commons was settled not by law, but by the fact that the technology was already obsolete by the time the protest was filed? Number 7. Luna 15, the Soviet spacecraft that was already crashing when Apollo 11 landed. On July 13, 1969, 3 days before Apollo 11 launched from Kennedy Space Center, the Soviet Union quietly sent its own spacecraft to the Moon. The mission's objective was classified. Its existence was acknowledged only in the vaguest terms. Its goal: to land on the lunar surface, collect rock samples, and return to Earth before the American astronauts could, remained officially secret from the watching world. Luna 15 reached lunar orbit on July 17th, the same day Apollo 11 was already en route. The Soviet spacecraft's presence was known to NASA, which was sufficiently concerned about potential radio frequency conflicts that Apollo 8 Commander Frank Borman was dispatched directly to the Soviet Union to negotiate a solution. The Soviets provided Luna 15's orbital parameters to ensure no collision with the crewed mission. They revealed nothing else. Neil Armstrong, in a 2009 interview, stated that he had not known about Luna 15 or its goal at the time. While Armstrong and Aldrin walked on the surface of the Sea of Tranquility, a Soviet robot was circling 554 kilometers to the north-northeast, completing orbit after orbit, waiting for its moment. The moment came too late. Luna 15 completed 52 orbits of the Moon across several days, while Soviet engineers back on Earth scrambled to calculate a viable landing trajectory. The Moon's gravitational field, still poorly understood in 1969, was causing the spacecraft to drift. On July 21, 1969, with the Apollo 11 crew already preparing for departure, Soviet leadership gave the final order. Luna 15 initiated its descent at 15:46:43 UTC. Transmissions ceased 4 minutes later. The spacecraft had crashed into a lunar mountain in Mare Crisium at approximately 130 meters per second, approximately 2 hours before Armstrong and Aldrin lifted off from the surface below. The entire descent was monitored in real time from Jodrell Bank Observatory in Cheshire, England, where British scientists were listening simultaneously to both missions on their radio telescope. The audio recording of their final minutes of observation, including a quiet, stunned voice saying, "I say this has really been drama of the highest order," was kept private for 4 decades, finally released to the public on the 40th anniversary of the Moon landing in 2009. 2 spacecraft from opposite sides of the most consequential geopolitical competition in human history occupied the same celestial body at the same moment, one openly, one in total secrecy, one triumphant, and one silent in the dust of Mare Crisium. And the only people who knew both stories simultaneously were a handful of British astronomers listening through a telescope in the English countryside. History rarely compresses its ironies so efficiently. Number 6. The Vela Incident. The nuclear flash that no government will officially explain. At 0:53 UTC on September 22, 1979, an American Vela Hotel satellite designated OPS-6911, a nuclear test detection platform orbiting at an altitude of approximately 111,000 kilometers, recorded a double flash of light above the sub-Antarctic Indian Ocean near South Africa's Prince Edward Islands. The pattern was unambiguous. The Vela system had been specifically designed to detect exactly this signature. The previous 41 double-flash detections recorded by Vela satellites had each been confirmed as atmospheric nuclear tests. The Vela program existed to enforce the 1963 Partial Nuclear Test Ban Treaty, which prohibited nuclear detonations in the atmosphere, underwater, and in space. By 1979, the detection system was well calibrated, extensively validated, and trusted by the intelligence community precisely because its track record was perfect. Satellite OPS-6911 was operating beyond its design lifetime. Launched in May 1969, it was more than 2 years past its expected operational end. But its pangmeter sensors, designed specifically to capture the characteristic rise and fall luminosity pattern of a nuclear detonation, returned a signal the analysts knew how to read. The optical light curve indicated a low-yield detonation of approximately 2 to 3 kilotons. The Arecibo Observatory in Puerto Rico independently detected an anomalous wave in Earth's ionosphere moving from southeast to northwest on the same date, a pattern previously recorded only in the wake of confirmed Soviet nuclear tests in the early 1960s. Sheep in southeastern Australia subsequently showed traces of iodine-131, a product of nuclear fission, in their thyroid glands. With studies of wind patterns from the Prince Edward Islands region confirmed that nuclear fallout could have reached southwestern Australia. The CIA assessed the probability of a nuclear test at, in the words of a declassified document released by the National Security Archive in 2019, 90% or higher. The White House established a scientific review panel chaired by MIT professor Jack Ruina. The Ruina panel concluded that the signal was more probably the result of a non-nuclear event, perhaps a meteoroid striking the satellite, and this became the semi-official government position. Former CIA Director Admiral Stansfield Turner later told researchers he had never taken the Ruina panel seriously. The intra-governmental controversy became, by 1980, openly acrimonious. Most independent historians and nuclear proliferation researchers today conclude the event was a low-yield nuclear test, widely believed to have been Israeli, possibly conducted in cooperation with South Africa, though both governments have maintained official silence. Some information about the Vela incident remains classified by the United States government. A nuclear detection satellite recorded exactly what it was built to record, in exactly the format that had confirmed 41 previous nuclear tests, and the official response was to establish a panel that decided it probably had not happened. Whatever detonated above the sub-Antarctic Indian Ocean on September 22, 1979, did so in one of the most remote locations on Earth, in a window when no active Vela satellite was listed as overhead, and whatever it was, it left traces on 3 continents that have never been fully explained. Number 5. The Iridium-Cosmos Collision, the first satellite car crash in history. At 1656 UTC on February 10, 2009, at an altitude of 789 kilometers above the Taimyr Peninsula in Siberia, 2 satellites that had been predicted that same morning to pass within 584 meters of each other simply failed to miss. The collision lasted a fraction of a second. Both spacecraft were destroyed instantly. The debris cloud that replaced them expanded through low Earth orbit in minutes, and it is still expanding today. Iridium-33 was an active American commercial communications satellite, part of the Iridium LLC constellation, providing satellite phone service globally, weighing 560 kilograms and launched in 1997. Cosmos 2251 was a defunct Russian military Strela communications satellite, 950 kilograms, launched June 16, 1993, deactivated in 1995, and left in orbit with no propulsion system and no means of active control. The two objects had been separately cataloged for years by the U.S. Space Surveillance Network. That morning, the conjunction prediction software Socrates flagged their close approach with a predicted miss distance of 584 meters. The warning existed. It was real. No collision avoidance maneuver was executed, partly because the uncertainty in orbital tracking routinely generates hundreds of similar alerts, and partly because Cosmos 2251, being dead, could not have been moved regardless. The relative collision velocity was approximately 11.7 kilometers per second, roughly 26,000 miles per hour. At that speed, two satellites do not collide, they detonate. NASA's initial estimates suggested over 1,000 debris fragments larger than 10 centimeters. By July 2011, the U.S. Space Surveillance Network had cataloged more than 2,000 large fragments from the impact. Peer-reviewed analysis confirmed this was the first accidental hypervelocity collision between two intact spacecraft in the history of space operations. As of 2024, the U.S. Space Surveillance Catalog still tracked 916 pieces of Cosmos 2,251 debris and 212 pieces of Iridium-33 debris in orbit, 15 years after the collision that produced them. The event had been predicted, not precisely, not with certainty, but predicted, by a paper published in the Journal of Geophysical Research in June 1978 by NASA scientist Donald J. Kessler and his colleague Burton G. Cour-Palais, which had modeled exactly this kind of cascading collision scenario and warned it was becoming statistically inevitable. The Iridium-Cosmos collision occurred 31 years after that warning was published, and in the exact altitude, regime, and debris density conditions that Kessler's model had flagged as the highest risk zone. Some debris fragments from the February 10, 2009 collision are expected to remain in orbit through the end of the 21st century. The cloud that formed above Siberia in under a second is still up there, still drifting, still generating collision avoidance alerts for every active satellite passing through that altitude band, a permanent and unremovable consequence of two objects failing to occupy separate points in space for a single moment. Number 4. The Kessler Paper. The 1978 warning that nobody acted on. In June 1978, the Journal of Geophysical Research published a paper by two NASA scientists at Johnson Space Center in Houston, Donald J. Kessler and Burton G. Cour-Palais, with the dry technical title, Collision Frequency of Artificial Satellites, the Creation of a Debris Belt. It was not widely read outside specialist circles. It did not make headlines. It was, however, one of the most consequential scientific papers published in the 20th century, and we have been living inside its predictions for decades. Kessler's insight was methodological as much as it was observational. By applying to the cataloged population of orbital objects the same mathematical techniques used to study the evolution of asteroid belts, he demonstrated that the density of debris in low Earth orbit had already reached a level where random collisions would begin producing more debris than atmospheric drag could remove. He was not describing a distant future scenario. He was describing a threshold that the orbital environment was approaching within decades. At the time of publication, the cataloged orbital object count stood at approximately 3,866. Kessler found that 42% of that debris was already the result of just 19 events, primarily explosions of spent rocket stages that no one had bothered to depressurize before abandoning them in orbit. The reception within NASA was not enthusiastic. Kessler's colleague Burton Cour-Palais later recalled being told by a supervisor to encourage Kessler to come up with solutions rather than problems. Kessler published anyway. In 1979, the findings resulted in NASA establishing the Orbital Debris Program Office at Johnson Space Center, with Kessler appointed as its head, a meaningful institutional acknowledgement, though the measures that followed remained largely advisory for decades. The term Kessler syndrome was not coined by Kessler himself, but by John Gabbard, a NORAD employee, in an interview shortly after the paper appeared, and the phrase entered the public consciousness through a 1982 Popular Science article. In 2009, 31 years after the original paper, Kessler published a follow-up assessment. Its language was precise, and its conclusion was not a prediction. It was a diagnosis. The debris environment in low Earth orbit had already become unstable, meaning that even if all new launches stopped immediately, the existing population would continue to grow through mutual collisions faster than atmospheric drag could clear it. In the same year, the Iridium-Cosmos Collision occurred, generating over 2,000 additional tracked fragments, adding to a population whose growth Kessler had identified as self-sustaining. One scientist, working with a dataset of 125 randomly sampled orbital objects in 1978, predicted with reasonable accuracy what the orbital environment would look like in the early 21st century. His supervisors asked him to stop raising problems. He published anyway. We are now inside the problem he described, and the question that lingers, the one that does not have a comfortable answer, is what it means that the warning existed 47 years ago, and that the structures of international space law produced in those 4 decades still contain no binding prohibition against the deliberate creation of orbital debris. Number 3. Fengyun 1C, the Day 1 country permanently poisoned in orbit. On January 11, 2007, without prior notice to any international partner, without any consultation with the United Nations Committee on the Peaceful Uses of Outer Space, and without any mechanism for remediation of what followed, the People's Republic of China launched a ground-based ballistic missile from the Xichang Satellite Launch Center in Sichuan Province and destroyed one of its own weather satellites in low Earth orbit. The satellite was called Fengyun 1C. It had been defunct since approximately 2004. What replaced it was something far more persistent. Fengyun 1C had been launched on May 10, 1999. It was a polar orbiting weather satellite approximately 750 kilograms, operating at an altitude of roughly 863 kilometers. In the heart of the sun-synchronous orbit band used by Earth observation satellites, weather platforms, and reconnaissance systems operated by dozens of nations. At that altitude, atmospheric drag is minimal. Objects released there do not fall in months or even years. They circulate for decades. The relative velocity of the interceptor missile and the target satellite at the moment of impact was approximately 9 kilometers per second. The collision was, by design, total. The debris field was staggering. The U.S. Space Surveillance Network initially estimated approximately 2,300 fragments larger than 10 centimeters. Later tracking revised that figure upward to over 3,500 cataloged fragments. The single largest debris-generating event in the history of space operations to that date, surpassing the combined debris produced by all previous fragmentation events in some altitude bands. China did not officially acknowledge the test until January 23, 2007, 12 days after it occurred. The debris field immediately began threatening operational satellites from the United States, Russia, Europe, Japan, and China itself. Because orbits at that altitude are shared infrastructure, and no nation's debris respects another nation's spacecraft. The most disturbing characteristic of the Fengyun 1C debris field is not its size, but its permanence. At 863 kilometers, atmospheric drag is so weak that some fragments from the January 2007 destruction are expected to remain in orbit until the mid-22nd century. They will still be circling the Earth when every person alive today is dead. The Fengyun 1C event directly accelerated the instability of the orbital environment that Kessler's 1978 paper had warned was approaching a threshold, and it did so not as an accident, not as a side effect, but as a deliberate demonstration of military capability. No binding international treaty prohibited what China did on January 11, 2007. The 1967 Outer Space Treaty bans weapons of mass destruction in orbit, but conventional anti-satellite weapons fall outside its scope. India conducted its own ASAT test in March 2019, destroying the Microsat-R satellite at approximately 300 kilometers altitude and producing roughly 400 additional tracked debris fragments. The orbital commons, the thin shell of near-Earth space on which GPS, weather forecasting, climate monitoring, and global communications all depend, has been deliberately degraded by the nations most capable of protecting it, and the legal architecture that governs it was written before the consequences were understood. Number 2. The treaty gap. The agreement that banned everything except what mattered most. On August 5, 1963, the United States, the Soviet Union, and the United Kingdom signed the Partial Nuclear Test Ban Treaty in Moscow. It was, by any measure, a remarkable diplomatic achievement, the first arms control agreement of the nuclear age, hammered out in the shadow of the Cuban Missile Crisis and propelled into existence by the shocking, unintended consequences of Operation Starfish Prime the previous year. Atomic Energy Commission Chairman Glenn Seaborg and Soviet scientists had both been alarmed by what a single nuclear detonation at 400 kilometers altitude had done to Earth's radiation environment. The treaty banned nuclear explosions in the atmosphere, underwater, and in outer space. It was a genuine milestone. It was also incomplete in a way that would define the next 60 years of space history. France and China, both nuclear-armed states, did not sign the Partial Nuclear Test Ban Treaty. France continued atmospheric testing until 1974, China until 1980. But the more consequential gap was structural, not political. The 1963 treaty and its successor, the 1967 Outer Space Treaty, together established a framework that prohibited weapons of mass destruction in orbit and banned nuclear tests in space. What neither treaty prohibited was the deliberate creation of orbital debris through conventional means. The 1967 Outer Space Treaty required nations to consult with one another before conducting activities potentially harmful to other nations' space operations, a provision that Project Westford's controversy had helped produce. But consultation is not prohibition, and the provision carries no enforcement mechanism. In the decades that followed, the Soviet Union, the United States, China, and India each conducted anti-satellite weapon tests that collectively added thousands of debris fragments to the orbital environment, each test legal under the framework that was meant to preserve space for peaceful use. The Vela Incident of September 1979 exposed the enforcement problem directly. A satellite built to detect nuclear tests in space detected what most independent researchers now believe was a nuclear test in the sub-Antarctic. And the political complexity of pursuing accountability under the treaty framework produced instead a classified review panel whose findings were disputed within the government that commissioned it. Project Westford's copper needle clumps, still tracked in orbit since 1963, were created under a classified military program that bypassed the consultation requirements that the program itself helped to produce. The Fengyun 1C debris field, still circling Earth and expected to remain there into the 22nd century, was placed there in full compliance with every binding treaty currently in force. The the pattern across all of these events. From the 1958 plan to detonate a nuclear weapon on the Moon to the 2009 collision between Iridium-33 and Cosmos 2251 is not one of recklessness without warning. The warnings existed. Kessler published his in 1978. The IAU protested Project Westford in 1963. The consequences of Starfish Prime were documented in real time. The pattern is one of legal frameworks that were written to address the dangers that were already understood, while the dangers that were not yet understood accumulated in the space between the clauses. The orbital environment that every human alive depends on today was shaped by decisions made without legal constraint, warnings ignored without legal consequence, and debris created without legal obligation to remove it. And the architecture designed to prevent exactly this outcome was incomplete from the day it was signed. Number 1. The Kessler Threshold, the point of no return that may already be behind us. In 2009, 31 years after publishing the paper that predicted it, NASA scientist Donald J. Kessler published a revised assessment of the orbital debris environment. It was not a new warning, it was a confirmation. The debris population in low Earth orbit had, by Kessler's modeling, already crossed into instability, meaning that even in the hypothetical scenario where humanity launched nothing further into space, ever, the existing debris would continue to collide with itself, generating new fragments which would collide with other fragments in a self-sustaining cascade that atmospheric drag alone could not reverse on any timescale meaningful to human civilization. The numbers, as they stand at the edge of the knowledge available here, are extraordinary. The U.S. Space Surveillance Network tracks approximately 27,000 objects larger than 10 centimeters in Earth orbit. The European Space Agency estimates roughly 1 million objects between 1 and 10 centimeters, large enough at orbital velocities to cause catastrophic damage to any active spacecraft, but too small for current surveillance systems to track reliably. The estimated number of fragments below 1 centimeter exceeds 130 million. All of these objects travel at velocities between 7 and 8 kilometers per second. At those speeds, a fragment the size of a marble carries the kinetic energy of a hand grenade. A 10-centimeter fragment carries enough energy to destroy a satellite outright, and every collision produces more fragments at more velocities across more orbital planes. Each item in this list contributed something to that population. The Starfish Prime radiation belt destroyed 6 satellites, and its artificial electrons lingered for at least 5 years, accelerating the degradation of early orbital hardware. Project Westford's undeployed clumps have circled Earth since 1963, each one a potential collision source. The Vela Incident demonstrated that the legal framework governing nuclear activity in space could be bypassed without consequence in the most remote geography on Earth. The Fengyun 1C debris field added over 3,500 tracked fragments at an altitude where they will persist for more than a century. The Iridium-Cosmos Collision produced a cloud that is still expanding. The Kessler Paper provided the mathematical proof that all of this was directional, not random. That the orbital environment, once it crossed a certain density threshold, would begin to destroy itself. And the treaty framework produced between 1963 and 1967, designed to preserve space as a commons for all of humanity, contained no mechanism to prevent any of it. Active debris removal technology is under development. Astroscale's ADRAS-J mission achieved orbital proximity to a piece of uncontrolled debris. The European Space Agency's Clear Space 1 mission is in preparation. The FCC has implemented a 5-year deorbit rule for U.S. licensed satellites. The 2023 Orbits Act authorized $150 million for NASA debris remediation research. These are genuine efforts conducted by serious people against a problem whose scale they understand with precision. None of them address the debris already in orbit. None of them reverse the cascade that Kessler's 2009 assessment indicated was already underway. They are, by the best available science, responses to a threshold that may have already been crossed. The history of near-Earth space is, in the end, a history of decisions that each made sense within their institutional context. A Cold War arms race that required demonstrations of reach, a communications vulnerability that required a creative solution, a legal framework that required the best diplomatic language available in 1963, a weapons program that required a visible test, and whose cumulative consequence no single decision-maker fully intended and no single treaty fully anticipated. The orbital shell that enables GPS navigation, weather forecasting, climate monitoring, emergency communications, and every future mission of human exploration was built across 60 years without a coherent framework for its preservation. And the process that now threatens it was not a failure of knowledge, because the knowledge existed, documented and published for decades before the consequences arrived. Everything that has ever been launched into space is still up there in some form. The copper clumps from 1963 are still circling. The electrons from 1962 shaped the environment for years afterward. The debris from 2007 and 2009 will outlive everyone alive today. And the cascade, if it reaches the tipping point in the most congested orbital bands, will not be reversible. Not in years, not in decades, not in any time frame that resembles human planning. Because the universe does not issue second chances to civilizations that mistake the edge of a threshold for open ground. If you want to see more videos like this, click the video on screen now and make sure to subscribe.